Today we're going to take a look at solving rational equations and rational inequalities. You want to start out by finding the LCD. So first of all, you got to start by factoring the denominators. Then you want to get each fraction to have that common denominator, so you need to multiply by special forms of 1. Once you get all the fractions to have the same denominators, you don't really need them anymore because everything's over the same. So you can just work with the top. So basically drop the denominators. And then you just solve it like normal and then check to see if it works. You need to check to see if your answer works because if you plugged in 3 in this problem right here, you would get a 3 minus the 3 on the bottom, which is 0, and you can't divide by 0. So we're going to start by factoring all the bottoms. So we're going to do the prime factorization of 24. We would factor this if we could, and we'll factor the 4. So prime factorization of 24 is a 2 cubed and a 3. 4 is a 2 squared. We now find your LCD, which once again is all the different things that show up, which are a 2 to a power, a 3, and then what we have right here underneath this, which is an x minus, or a 3 minus x. Remember, if you have a choice in the exponents of a 2 cubed or a 2 squared, you always take the higher one. So that's what we want to try to get for each denominator. So this first fraction has the 3 and has the 2 cubed, but it doesn't have the x minus 3. So I'll put an x minus 3 on the bottom. If I multiply the bottom by x minus 3, I also need to multiply the top by x minus 3. For the second fraction right here, you'll notice I have the parentheses, but I don't have what's in front of the parentheses. So I need a 3 and a 2 cubed on the bottom to get that common denominator. But if I multiply the bottom by that, I got to also multiply the top by that. So this right here is a special form of 1 because the top and the bottom are the same. This is also a special form of 1 because the top and the bottom are the same. And remember, multiplying by 1 doesn't change the value, it might just change the appearance. Then the last one, I'd have to multiply the bottom by this, so I multiply the top by this. So I'm going to multiply these two fractions together. So multiply the tops, multiply the bottoms, and I get this right here. Then in my big plus sign, multiply these two fractions together. And then on the right-hand side, multiply the tops, multiply the bottoms, and I have this. So once everything has the same denominator, when I'm solving it, all I have to do is really work with the top. So I'll just drop the denominators, work with the top, so I'll have this right here with a plus sign afterwards. Then I'll have this right here, equals, and I'll have this top over here. All I have to do is just solve that. So I can distribute through, work out this, distribute through a 6. So my 15 minus 5x comes from this here. Multiply this together, I get my 48. Distribute through my 6. 6 into 3 is 18. 6 into negative x is negative 6x. Collect my like terms on the left side of the 15 and the 48. Then I can go ahead and try to solve it for x. So I'm going to go ahead and add 6x to both sides. I get this here. Subtract a 30 or 63 from both sides. I get this here, and I get my x to be negative 45. The only thing I have to do at this point is double check. Does negative 45 cause me to get a 0 on the bottom? Well, there's no variable here. Don't have to worry about plugging in. No variable here. Don't have to worry about plugging it in. And when I plug it in right here, 3 minus a negative 45 is not 0. So negative 45 is my answer. So that's what I have to do for all these rational equations. Find my LCD, so I need to start out by factoring the denominators. The first one doesn't factor. The second one over here on the other side of the equal sign is really differences of squares on the bottom, so that's going to factor into a p plus 1, p minus 1. This one here is really a p over 1, so that denominator doesn't factor. Your LCD is all the different things that show up in the bottom, which would be a p plus 1 and a p minus 1, and that's your LCD. So you want to rewrite this one right here so that each fraction has that common denominator. This first fraction is missing a p minus 1 on the bottom, so I'll multiply the bottom by a p minus 1, and I'll multiply the top by p minus 1. The second fraction on the right-hand side, well, first fraction on the right-hand side, second fraction from left to right, already has that common denominator. The third fraction over here needs everything on the bottom, so then you're going to multiply the whole top by that also. So at this point, I'm going to multiply these two fractions together, multiply the tops, multiply the bottoms. Over here, there's nothing to multiply together, it's just going to stay as is. I'm going to multiply these two fractions together, multiply the tops, multiply the bottoms. Once everything has that common denominator, it's really no longer needed, so all I have to do is just work with the tops. I have this right here, have this top, and then I have this top. Technically, the top is called the numerator, the bottom is called the denominator. So on the right-hand side of the equal sign, I'll still have this here. Then I have to FOIL this. After I FOIL, I distribute through a p. By the way, when I FOIL, I get a p squared minus 1, distribute through the p, so I get this. Left-hand side, you're going to have to distribute the p squared to each one here, distribute the negative p to each one, distribute the positive 1 to each one, and I get this here. Now, you'll notice here, I have cubes on the left, I have cubes on the right, but if I subtract a 1p squared, or 1p cubed from both sides, that they end up dropping. So that's gone, and that's gone. You'll notice the highest power left is a squared. So that just means it's quadratic. So I need to bring everything over and set it equal to 0. So I'm putting 0 on the left side. I have a negative 2p squared here, so I'd have to add a 2p squared to both sides. So 1p squared plus a 2p squared is a 3p squared. This is a 2p, so I have a positive 2p. I need to take that to the other side, so I need to subtract a 2p from my negative p, so I get this. And then I did have a minus 1 here, so I'd have to add 1 to both sides, and negative 7 plus that 1 is a negative 6. So I'm going to factor this, or I could use the quadratic formula if I wanted, but I'm going to factor it, so I'm going to pull out a 3, and then my greatest common factor. Factor what's left in the parentheses. Now I have several things multiplied together, actually 3 things. So then I can set each thing equal to 0. Now, in this case, is my 3 ever going to be equal to 0? No. 3 is just 3. But could my parenthesis here ever be equal to 0? Yes. So I'll set that equal to 0, and I get 2. Set the last parenthesis equal to 0, and I get x, or p, to be negative 1. Now, in this case, it's only p equaling 2 that works. Because if I take that negative 1 and plug it into the original, it causes me to get 0 on the bottom. So let's go up there and double check with this one right here. If I take that negative 1 and plug it in here, negative 1 plus 1 gives me 0 on the bottom, and I can't divide by 0. So I cannot use that. That's referred to as an extraneous solution. So my only answer is p equals 2. So let's go ahead and do this one here. Factor the bottoms, find my LCD, multiply by special forms of 1 for each fraction. Don't have to worry about doing that right here because it already has that. This one here needs p minus 2 top and bottom. Write this as one big fraction. We already have one big fraction there. Multiply these two together. Once again, when everything has the same denominator, you can drop the denominators, work with just the top. So this is a p plus 4. This is a 2x plus 1 on top, the plus sign, and then a 2 times the parentheses here. Then all we have to do is just collect like terms on the right-hand side, solve it for x, so subtract an x from both sides, add a 3 to both sides, and I get x to be 7 over 3. Just double check your answer, plugging it into the original to make sure it doesn't cause you to divide by 0, which it doesn't, so our answer is 7 over 3.